it's the first project that I made in Go. Net stuff is kind of abstracted away to test applications that I built with this framework, just to kind of show what this framework is about. Here we have a chat application. This I did not see in online tutorials that I have seen. Cool and asynchronous, and like everyone loves. Hi, I'm gonna be showing you a networking framework that I'm still kind of developing. It's not a final version by any means. I don't actually know what kind of functionality I want to add to that framework, but basically it's the first project that I made in Go language. It's a TCP/IP networking framework, so it's intended to be used to develop server and client side applications. And I actually think I might make a tutorial in the future on creating a similar kind of networking framework. Yeah, so I'm not gonna go into the code of the actual framework just because it's not finalized at all, and because there is a lot of to unpack here. But I did use channels, I did use go routines, I did play around with a bunch of stuff. I use mutices, I use mutices, I use wait groups and stuff like that. So it was a cool kind of learning experience. But in this video I'm just gonna show you the apps, the two test applications that I built with this framework, just to kind of show what this framework is about. This is a test application, and as you can see here, I do not import net package. So net stuff is kind of abstracted away, but obviously you have a way, the user of the framework has a way to access kind of raw net.com structures, so connections, but you don't have to. And here in this test application we don't actually even import net package. So the first thing that we import is obviously the framework, which is kind of, it's a cool package management system that Go has, and here you just specify the path. So yeah, it's on github.com, but the thing is, as I'm recording this framework, the repository for this framework is actually private, so you actually cannot use it. I will soon make it public. I just wanna once again finalize some stuff. Okay, so, and these are just application specific packages that we use. I'm not gonna go like just line by line, I'm just gonna show the most general things that relate to this framework. First off, we have this struct type, which is myClientHandler. And myClientHandler is an interface. It's an interface that requires you to implement three methods: onClientConnect, onClientDisconnect, and onClientMessage. And as you can see here, we implement those here. So the framework is asynchronous. onClientConnect, we get server instance, a pointer to the server instance, so the instance of a server that we start, and an ID of the client. And onClientConnect, we simply just print out a new client with this ID has been connected to the server, this server. On disconnect, the same thing, we just print out a message. And remember that this is a server application. On client message, so when we get a message from a client, we get its ID and a message itself, the message itself. We print it out just for debug purposes, and here we check. Basically, this test application is a chat. Multiple clients can chat with each other, so it's like a chat room. So message has two fields, type and body, and type is simply a string, and body is also a string. So it's just a convenient differentiation between, so we can quickly check the type and then work with body accordingly. So this test application actually allows clients to set nicknames. If a nickname has been set, we set in the nickname, or if a client did not set a nickname, then we just use the client ID. If the chat message has been sent to the server, then the server simply creates a response message which is a chat message with a nickname, with a string nickname, colon, space, and the message itself. And then we use this method of server instance send all. So we can send either to the particular client by using an ID, or we can send to all clients. Else, if a message type is set name, then we set a name. So basically, a client can set a nickname, and that nickname is going to be associated with that client during the session. And here we use mutex because it's all asynchronous, and client names is a map. Keys are client IDs, and values are strings nicknames, right? Then we have another interface implementation, myServer updater, which implements onServer update. And onServer update, basically it's the main server update function. And here we get a scanner from server state and simply check for console input, and we can say exit, for example, and it's gonna stop the server instance, and the server is gonna stop. So here we can create as many commands as we want, and here I use scanner for console input. Now the cool feature is this server state, so you can create whatever struct you want. It doesn't even have to be a struct, it can be simply an integer or a string, but basically it's here I create a struct myServer state, and here I describe an application specific state. So basically in server instance here it has state interface, and interface, this empty interface, it's whatever type you want. So here we create a struct myServer state, and we later pass it on to the server instance. And so here, as you can see, we use that all throughout on client message method. And here we store application specific data. And here I have scanner and client names map and a mutex, because map is not thread safe. If we access map, you know, simultaneously from different Go routines, then it's gonna be a problem. And to avoid that, we use a mutex. And here is the main function. Basically, we just create these variables for interface implementations, for client handler interface implementation, and for myServer updater interface implementation. And then we create a struct myServer state struct, and here we create a scanner which is stdin, so it's a console input. Then client names, we just allocate a map and a mutex. And here is the only function call in the main, and so then everything is asynchronous. Here we simply call start server, we specify a port, it doesn't matter which port we specify. Here I specify 8080, which is I think HTTPS port. For some reason, I don't know why I chose it. You can specify whatever one you want. Then we provide a implementation for the client handler interface, for the server updater interface, and whatever state we want. And if we had some problem starting a server, this function is gonna return error. So we check if error is returned, then we simply print it out. And basically that's it. It's really simple, 100 lines of code, and that's it. And now let's go to the client chat application. By the way, I called the framework Hurlin. I wanted it to be pronounced Hurlian or something like that, but I call it Hurlin because just the way you read it. So Hurlin, I don't know why. So here we implement an interface, my server message handler, which only has only one method on server message. It's gonna be called when the server sends us a message. And here we basically check if the type is chat message, then we simply print it out into the console. Another interface implementation is my client updater. Much like server updater, it also has one method on client update, which is basically the kind of main loop, if you will. And here we also get an input, a console input, and here I just basically you can either type out a message to send to the chat, or you can type out a command that starts with, you know, slash, for example, disconnect, and it's gonna disconnect or something like that. You know, in chats they have that thing. And basically here we have disconnect command and set name, which enables clients to set nicknames for themselves. If we type out a disconnect command, then we're gonna disconnect. If we set name, then we generate a message of type set name and send it to the server. And if we just type out a chat message, then we send it to the server as well, just the type is gonna be chat message. Also, there is such a thing as client state, and this one in particular only has scanner. The reason why it's even the scanner is in the state is because we only have to initialize the scanner once. It would be kind of a waste to initialize the scanner on each update, so I've decided to have it in the state. We can specify whatever else we want. We can have like text string, and basically we can have here like text hello. Okay, so that's how we connect to the server. We provide an IP, a port, then implementations to the interfaces, and a state. Everything is done asynchronously. So let's actually test this chat application out. So we're starting up a server. Next, let's start up a client. Here is the message on the server. A new client ID 0 has been connected to the server. Good. Let's print out hello, for example. Here it prints out 0, hello. So the message from client with ID 0, type chat message and hello. Okay, good. Let's connect our other clients call run dot. Perfect. Okay, and let's here have set name, I don't know, John. Okay, so client 0 has set name to John. So now if we type hi all to the chat, as you can see, to every other client it's also sends these messages, John hi all, hi all. So basically, as you can see, when we type something in the chat and send it from the client, it sends it to the server, and the server sends to all the clients the message. Let's, for this client, set name to, I don't know, cat lover 89, and let's say cats or dogs. And as you can see, we chat. Now we can chat. I am a cat person myself, and here we can say dogs rock. So John sends a response. So here we have a chat application, quite simple. You know, I wanted to control all the Go routines to make sure that all the Go routines stop if the server stops, for example. So here, if we say exit, you know, client read had stopped, so all the clients have stopped as well. It's not just crashing. Let's stop all those. And as you can see here, sender is a Go routine. So we have multiple Go routines for each client, so that it's all concurrent and asynchronous. And so yeah, here we stop all of those, and basically we handle, you know, on client disconnect and all of that. It's just I spent some time, you know, figuring out how to make how to handle all the disconnects. For example, if the client disconnects, it's also disconnect. As you can see, client has disconnected and the Go routines are stopped. So yeah, that's I think really important. And the server goes on like, yeah, disconnect, exit. So yeah, and this particular thing, like the handling of all the Go routines that have been created, so that they're not just forcefully being closed, this I did not see in online tutorials that I have seen. So I might make a tutorial on creating this kind of TCP networking framework and handling all that. In theory, we could actually... No, we probably couldn't. Yeah, we could, in theory, create multiple server instances, so it's very, I guess, versatile in that sense. You know, because we're using server instances, so it's all kind of like cool and asynchronous, and like everyone loves. The code is gonna be public soon. If you wanna check it out, I'm gonna leave a link in the description, and probably in a couple of days I'll make it public once I kind of finalize it. I also don't know if it's any good, like it's my first project in Golang ever. So yeah, like you already can create a chat application with this framework, so I guess it's decent for what it is. Thanks, and let's stop on this cool looking, you know, view. Cool view. Bye bye.